This next video is on annuities. So I'm just going to explain a little bit of what an annuity does, and then we'll use this formula in the yellow box. So imagine that you're going to invest small amounts at periodic intervals into an account, like a savings account. Let's say you want to invest $1,000, and at the end of each year you retire, you're going to have in a certain amount in your account, and you want to be able to find out how much are you going to have at the end of that investment. So there's the formula in the yellow box that we're going to go ahead and use. So the A is the end amount, the P is the deposit made at the end of each compounded period, and then the R is the interest rate as a decimal form. The compounds is the times per year that compounds exists, and then A is the end amount, and then T is the time in years. All right, so we're going to go ahead and move on to our first example. So our first example, for example 7, is at the age of 25, you start a retirement account. You decide to deposit $200 at the end of each month. And the bank pays you 7.5%, and it's compounded monthly. How much are you going to have in your account, in your IRA, at the end of your retirement, which is, let's say, 65? So we need to go ahead and identify the principal first, the initial amount. So the initial amount is $200. And as every month you're going to deposit $200 more, $200 more, $200 more. The R value is your interest rate, so that's your 7.5%. As a decimal, it is 0.075. The number of compounds is how often it compounds, so it is compounding monthly. So that is 12 times per year. And then the time is how long you're going to invest for. So you're starting at the age of 25, and then you finish at 65, so that's 40 years. So we're going to go ahead and substitute those 4 numbers into our formula. A will be our end amount. So $200 is investing every month. Interest rate as a decimal. Number of compounds per year, 12 because it's monthly. Again, 12. The number of years is 40 minus 1. And then all over that interest rate again over the number of compounds. My suggestion is that you would not substitute this all into your calculator in one shot. I just dropped something on the floor here, so just give me a minute. I wish this recording that I use had a pause button, but I've switched to a different program and it doesn't have the pause button. But I like using the iPad instead. So I'm just going to go ahead and change colors, and these are the suggestions that I would simplify before you substitute it into your calculator. All right, so let's go ahead and do that now. So 200 stays as it is. We're going to simplify that parentheses, so 1 plus 0.075, and then dividing that by 12 will give you 1.00625. And then 12 times 40 is 480 minus 1. And then all over, and then you want to simplify that denominator. So 0.075 divided by 12 is a decimal of 0.00625. Then I feel like you're probably comfortable to type that into your calculator. So in the end, the amount that you would have in that IRA would be about $604,765 after 40 years. In Part B, it asks us to find out how much interest you made. So imagine you're still depositing $200 a month, and you're doing that for 12 months and for 40 years. So let's figure out what is that total deposit. So how much are you depositing over the course of that 40 years? So it's $200 a month, 12 months for 40 years. Multiplying those three numbers together is $96,000. That's how much you're investing over 40 years. How much did you start? Not start with, how much did you end with? You ended with the value of your IRA, and then you're going to subtract out how much you deposited over that 40 years to get you how much you made in interest. So your interest that you earned is the value of the IRA, $604,765, minus how much you deposited over that 40 years. You subtract that out, and the interest that you made on your account is $508,765 was your interest.